All right, number 3 for the constructed response. The function f of x is defined as f of x equals x squared plus 2x minus 4. G of x is negative 3 times f of x plus 2. And the first part, they just want us to graph g of x for a certain amount of domain, so between negative 2 and 2. So this is as simple as graphing the function. So I'm going to go to y equals, I'm going to type in negative 3. In parentheses, I'm going to put the f of x function, so x squared plus 2x minus 4, and then I'm going to put plus 2. I can type it in exactly like that, or I can go ahead and expand it out. If I expanded it out, it would be negative 3x squared minus 6x plus 12 plus 2, and the 12 plus 2 is 14. So I could type in this if I wanted as well. It's the same thing. So now I'm in y equals, I type that in, and then I can hit second graph. And when I hit second graph, the only values I care about on my table are when x is negative 2 all the way up to 2. So now I have graph paper, so I'm just going to use my graph paper and plug in those values, and I'll show that here. And I went ahead and copied down what I saw from my table on second graph. So negative 2, 14, that's left 2 up 14, that's going to be somewhere up here. Negative 1, 17, that's somewhere up here. And on your graph paper you can make it a little better than what I'm doing, because my graph only went up to 10. And then 0, 14, it's right back to here. And then 1, 5 is down here. And then 2, negative 10 is, if I can get there, 2, negative 10 is going to be, let's see, right about there. So now I'll just connect that, because this is a function, I want to connect them. And those values are closed. The reason I know those values are closed is because this has a line underneath of it, so x is between those values and it can be equal to those values. So that's all you need for the first part. So not too hard, you just type it in the calculator and look at your table for that. All right, part 2, describe the transformations that take the function f of x onto g of x. All right, so how do we go from f of x to g of x? Well, let's look at what we did. We multiply the whole f of x by negative 3. So there's probably a couple different ways I could describe this. I'm going to say that I dilated it by multiplying by negative 3, and then I translated it. The reason I know this is a translation, I'm adding to the function, so that translation is going to shift it. In this case it's positive, so positive on the y value is up, so I translated it up 2 units. But I want you to see something. Whenever we multiply by negative 3, that's going to make that lead coefficient for the x squared a negative. So that's also going to be flipping it, or reflecting it. So we could also say on the dilation part that that is also a reflection. And this would be a decent answer. Now, I think a better answer might be breaking this down to understand really what's happening. So let's break it down. What if I were to just multiply f of x by a negative 1? What would happen then? I'm going to graph f of x in green. So f of x is going to look something like this. I'm not being exact, but I'm being pretty close to what it looks like. So that's f of x. And then what if I were to multiply everything by just a negative 1? And I'll show that with the blue. And it will look something like this. And if I drew that a little better, you could see that this is actually a reflection along y equals 0. So along the line y equals 0, that would actually be a reflection. So we could reflect it along y equals 0. And this is asking for the transformation. So reflect along y equals 0. And then we could say, now we're dilating each of those values by 3. And I'm guessing that both of these answers would be perfectly fine, but I just wanted to show you a different way to look at it. So dilated by 3, because it was really a negative 3, wasn't it? So now what that does is that actually makes this go up way higher than it did before, because it's tripling each of those numbers. So we could say reflected along y equals 0, it's dilated by 3, and then it was translated up 2 units. Either way, you have to have the translation in there, you have to have the dilation in there, and you might want to mention that it's reflected because the lead coefficient is changing, so that's going to be some type of reflection on whether it opens up or opens down. Okay? Alright, the third part of number 3. Write a new function h of x that transforms g of x back onto f of x. Alright, now this one is as simple as we need to figure out how to solve for f of x. How to solve for f of x. Right, because we want to go from g of x back to just f of x. So what are the steps I would do? Well, I want to get f of x by itself, so I would subtract 2 first. And then I'd have negative 3 times f of x equals g of x, and that looks like I'm dividing, I'm not. That was just when I underlined g of x. So g of x minus 2. And then if I'm multiplying by negative 3, I still want to get f of x by itself, so I divide by negative 3. Or I could multiply by negative 1/3. So times negative 1/3. It's the same thing. If you multiply by negative 1/3 or divide by negative 3, it's the same thing. The 3's still cancel because they're on the top and the bottom. So f of x is by itself, and we're multiplying this whole thing by negative 1/3. So actually, that's going to be my answer. So, but they're saying I need to call it h of x. So I would say h of x equals negative 1/3, parentheses, g of x minus 2. And that's it for number 3.